So after the power flow diagram, we are about to discuss a numerical problem in this topic, power flow diagram. So first I read the question. A 3-phase 400 volt, 50 Hz induction motor takes a power input of 35 kilowatt at full load speed of 890 rpm. Which of the total starter losses are 1 kilowatt and friction and windage losses are 1.6 kilowatt. Calculate option A shaft power, option B efficiency. So first I separate the given datas which are given in the question. Given datas, your starter voltage V1 equals to given 400 volt, frequency given 50 Hz, your starter power input, that is P in to the starter is given 35 kilowatt, is given 35 kilowatt, and full load speed, that is running speed at full load, NFL NR rotor speed at full load equals to 890 rpm revolution per minute. The total starter losses, that means core loss plus copper loss in starter, total starter loss is given 1 kilowatt, is given 1 kilowatt. Friction and windage losses, these two losses added, is given as friction plus windage losses, also known as mechanical losses or rotational losses, is given as 1.6 kilowatt, is given as 1.6 kilowatt. What do we have to find? The shaft power, that is the rotor output shaft power, that we have to find, and efficiency, percentage efficiency we have to find. So how I proceed in this question? First, you have given the starter power, starter input. From that we have to proceed to the output. So between these we have to subtracting the losses from the starter input. We proceed toward the shaft power output. So before this, first I have to determine the slip. For this slip, I have to determine the synchronous speed, but there is no data about the pole of the machine. So how can I find the synchronous speed? From here you know that the rotor speed is 890 rpm. If your rotor speed is 890 rpm, you have to find the nearest synchronous speed. So your nearest synchronous speed for a 50 Hz machine, for 50 Hz, your nearest synchronous speed for that will be 1000 rpm. Your NS will be 1000 rpm. That will directly come, because for the rotor speed you have to find the nearest synchronous speed, because if synchronous speed is nearest to the rotor speed, then your slip will be minimum and rotor couple losses will be minimum and power, air gap power will be maximum. So you have to choose the nearest synchronous speed, that is 1000 rpm. So after that we have to find the slip. S is equal to, already formula you are acquainted with, NS minus NR divided by NS. NS minus NR divided by NS. What will it come? 1000 rpm minus 890 rpm divided by 1000 rpm. It will come 0.11. It has no unit, it has unitless. Slip is 0.11. That you find the slip. After that you have to subtract the power, subtract the different losses from the starter input. Your starter input is question here mentioned, it is 35 kilowatt. So if I have to find the air gap power PG or rotor input PG is equal to starter input minus total starter losses, Your input is 35 kilowatt minus total starter loss is in the question, it is given 1 kilowatt. So minus 1, it will come 34 kilowatt. Unit is kilowatt. Your rotor input or air gap power is 34 kilowatt. Then after that, from rotor input, we have to find the shaft output. How we can find the shaft output from the rotor input? It will be PG minus rotor copper loss, PG minus rotor copper loss minus friction plus windage losses, friction plus windage losses. In this question, PG is, we also already find PG is 34 kilowatt. Friction and windage loss is given in the question, but what is the rotor copper loss? For that, you have to determine the slip. We already determined the slip. So your rotor copper loss equals to S into PG, is equal to S into PG. So it will come S into your rotor copper loss is S into PG. Directly you can also mention, if we ignore the rotor copper loss, directly you can find the formula. For mechanical power. But if you have to find the rotor copper loss, it will be S into PG. S is 0.11 into PG. PG is 34 kilowatt. PG is 34 kilowatt. So 0.11 into 34 kilowatt, it will come around 30.26. It will come around 30.26 kilowatt. It will come around calculate this, it will come around 2.8 kilowatt. It will come around 2.8 kilowatt. 3.8, around 3.8 kilowatt. It will come around 3.8 kilowatt. So you have to calculate the shaft power, which is equals to PG, which is given 35 PG, your PG, which is 34 kilowatt. It is 34 kilowatt minus rotor copper loss, which is 3.8 kilowatt, minus friction and windage losses, which is given in the question, is 1.6 kilowatt. It will come around shaft power, it is come around 28.66 kilowatt. 28.6 kilowatt. So your output, how we find the output? PSH, it is from the air gap power. From the air gap power, how we find the air gap power? It is the input starter power minus the total starter losses, that will find the input power to the rotor, that is known as air gap power. From the air gap power, we are subtracting the rotor copper loss and friction and windage losses to find the shaft power. How we find the rotor copper loss? It is equals to the S into PG. Slip, we are already determining the slip is 0.11. Slip into rotor power input or air gap power. This will give the rotor copper loss, which is come around 3.8 kilowatt. Then finally the shaft power, which already formula mentioned here, PG minus rotor copper loss minus friction windage losses, will come around 28.6 kilowatt. So it is the shaft power, which is the option A part of the question. So how we find the efficiency? Already I told the formula, efficiency is the output, which is the shaft power output, divided by input, which is the input to the starter. Input to the starter is already mentioned in the question, which is the 35 kilowatt, and your shaft power output we already find out 28.6 kilowatt. So 28.6 divided by 35, which is come around 82%, 81 point something, which is come around 82% into 100, into here we mention into 100, it will percentage efficiency will come around 82%. So how we solve the question? From the given data, we found the synchronous speed. Synchronous speed is the nearest, if no pole and frequency mentioned, in this question there is no pole mentioned. So for 50 hertz for 890 rpm speed, the nearest synchronous speed is 1000 rpm. So from the synchronous speed and the rotor speed, we found out the slip, because your slip is required to find the rotor copper loss. So slip will come around 0.11. So from this, we next step we find the rotor input. Rotor input or air gap power PG is equal to stator input minus total stator losses. In total stator losses, there are two losses: stator core loss and stator copper loss. This combined to give you the total stator losses, which is 1 kilowatt mentioned in the question. So PG or rotor input is equal to stator input minus total stator losses. So 35 kilowatt minus 1 kilowatt, it will give you 34 kilowatt. So after the rotor input or air gap power, we find the rotor copper loss. Rotor copper loss is S into PG, which will give you 0.11 into 34, around 3.8 kilowatt. So after that, we found the shaft output, that is the rotor input minus rotor copper loss minus friction plus windage losses. So friction plus windage losses given in the question 1.6, and you find out the rotor copper loss, which is 3.8. So PSS is equal to 34 minus 3.8 minus 1.6, around 28.6 kilowatt. So your efficiency will be output, which is the shaft output, shaft power output, divided by your input mentioned in the question, that is the starter input, equals to 35 kilowatt. So 28.6 divided by 35 into 100, this will give you 82% efficiency. Thank you.